All right, we're doing the Leetcode for July 3rd. It is 3304. Find the kth character in the string game one. First time looking at this, and we're gonna try to solve it. It's easy. And let's give it a shot. So Alice, while playing a game initially, Alice has a string word A. You're given a positive integer K. Now Bob will ask Alice to perform the following operation: generate a new word, changing each character and word to its next character in English alphabet, and append it to the original word. Okay. For example, performing operation C generates CD, and performing operation ZB is ZBAC. Got it, because Z goes to A and B goes to C. Okay. Return the kth character in the word after enough operations have been done to the word to at least have K operations. Okay. This is an interesting problem. So we're looking for the fifth value. So it would be A to B. Sorry, it would be A, which would become AB. Then it would be B. Then it would be BC in addition. I'm just trying to think if there's a way to optimize this, or we actually want to go through each value. I think for now, I think what does K go up to? K only goes to 500. So yeah, we don't have to worry about optimization really. Um, really, so yeah, what I'm thinking about is since we don't really know kind of when we hit this K value, we're gonna want to use a while loop. Um, And what's interesting actually is that there's no input for the string. I thought maybe we'd start at like A for example, or like we'd get a string, but it looks like it's the same for each generation. So we're always going to start with A. Um, right? Yeah, word equals A. Okay. Word equals A always. So that kind of is interesting. So while the len of word is less than K, so then, and then we're looking for the at least K characters. So that means that if we have len k, that means if the len of the word equals k, that means we hit it. So we can just return, yes, like if we have k characters, that means we can return the last value. Perfect. And then we essentially want to do an ORD. Um, or is this going to be computationally efficient? I think it is. If it's 500 times, yeah, it's gonna be fine. So for each char in Word, right, we want to have like a new string, uh, appended, which is going to be equal to that. And this is going to be the value we'll accumulate over the for loop. And essentially, we'll just take each char and add one to it. So we get the ORD of it, gives us like the value of it. And now how do we go back from ORD? I don't know how to go back to string. So if I do string of B, will that work? Um, I'm actually I'm gonna test that right now, actually, right here. If I do print of like board of or string of like 97, right? That's like A, I believe. No, it printed 97, right? Um, let's actually do a quick Google. Convert board to string Python. Spelled Python wrong, but okay. Converting string to ASCII. convert ASCII to string. That's what we want. Python. And so you want to do a char. Got it. Okay. Yeah, you want to distribute char. Okay. It should be A. Perfect. Okay. So that's good. And so this should be char. Or is it char like that? And ended plus equals char. And then what we're going to do here is we're going to extend word. So the thing we accumulate for each loop, we'll extend it. And it. We could do extend. No, that's not right at all. It's just plus equals, not extend. That's an array thing. So I think that looks good to me. I'm gonna give this a shot. Okay, we're not getting the right value. Let's print word. Let's just see kind of what we're getting here. Not exactly sure what's up. Interesting. Get AB. So for the first one, we should have A, B, B, C, B, C, C, D. That's right. I think we're just having an off by one issue. Wait. Sorry. This should not be. This necessarily doesn't always have to be -1 because sometimes we go over. Right, so, okay. The issue is that sometimes this is on an order of magnitude of, we're doubling the length of this every time, so it's 2 to the 3, 2 to the n. The size is 2 to the n. So sometimes k is in between the 2 to the n value. It's not always going to be the last value. So if we put k, it should be k minus 1 too. Okay. Oh, come on. Yep, looks good there. Let's see what happens if we do this. And we get a perfect, nice solution. Yeah, I thought perhaps maybe time complexity would be an issue, but no. Because it's like 2 to the, it's not 2 to the 500, is it? No, it's 2 to the, is it 2 to the 500, which is what? No, obviously it's not that. How big can this list get? No, the len. K is 500, so it only ever goes up to, like 2 to the 15th, right? Because like K is always going to be less than, no, not even close. 15. Let's do 8 maybe. 9. So it only ever, yeah, it only goes 2 to the 9th is the max number of length for the for word of A. So really this is bounded to O of 1 in terms of we're always going to have a maximum of 2 to the n length for word. So the memory is bounded, and the time complexity is also bounded by 2 to the n. 2 to the 9th. Since we have this kind of easy constraint here, we could have had very much increased this value a lot more, and it would have been the same problem. But yeah, that's 3304 for you.